the midpoint formula. So let's recall that a midpoint is a point that bisects, which again means cut in half or divide into two congruent parts, a segment. So we're going to start with just looking at a horizontal line and a vertical line and then carry that over into a coordinate plane. So let's say we're on a horizontal line and we have one point x1, so our x-axis runs horizontally, and another point x2, and we want to find a midpoint value. So we can look at this, and visually we know our midpoint should be somewhere around there so that this segment and this segment are congruent to each other, right? So what would the value of that midpoint be, and how do we calculate it? That's what we're aiming to discover. It might be easier if we start with some numeric values, and we can carry that over into a more abstract view. So let's say this is a 1, and here I'm at 5. We know that the distance between these two is 4, so halfway should be counting 2 off from either direction, and we know our midpoint value in this case is 3. In general, how do we calculate that? You are going to take the average of the 2 points. And you can see that that works with the numeric example. Taking the average, if we just add these up, so this equaled 5 plus 1. How many do we have? We have 2, right? And that verifies the 6 over 2, which is equal to the 3. So if we just average our two values, we can find the midpoint between them. So in general, our midpoint formula, this point here, will be represented by averaging out our x coordinates. And the same concept carries over to a vertical line. Here we're going to be dealing with a y-axis. We have 2 points on our y-axis. Let's look at 2 different numeric values. How about -2 and let's say 7? That is a distance of 9, so I'd want to count off 4.5 to get to my midpoint value. And our midpoint value in this case would be 2.5. Let's verify that through some math. So let's say we know that the midpoint is going to be the average of the 2 endpoints of our segment. So we have -2 plus 7 divided by 2 equals 5 divided by 2 equals 2.5. So that does in fact work out. But again, let's come up with the generic formula that we would use. Let's say this is our y1 and this is our y2. We can call our midpoint between them the average of those 2 values. Now, in the case of the coordinate plane, we're going to be dealing with xy coordinates, right? Let's recall that the x-coordinate controls distance and direction in a horizontal fashion. So this is horizontal distance and direction. Whereas the y-coordinate will give us vertical distance and direction. If we plot 2 points in our coordinate plane, and we would like to find the midpoint between them, let us first label this as x1, y1. And let's label this as x2, y2. We have a rough sense, so let's actually connect these with a segment. We know roughly where to expect the midpoint, but we want to be able to calculate precisely where that would be. Now what we can do is we know how to calculate a midpoint on a horizontal and vertical line. And therefore we can say that if we calculate the midpoint of our horizontal distance traveled between the 2 points and the midpoint between the vertical distance traveled, if we take that coordinate pair, that should reveal the midpoint of the segment that is shown here. So I'm going to add in another point, and we will call that x2, y1. Okay, horizontally, this point has traveled the same horizontal distance as this point up here, so its x-coordinate should also be x2. In terms of its y-coordinate, it has traveled the same vertical distance as our point over here on the left, so its vertical component should be y1. And again, based on what we've already discussed, we can calculate the midpoint of our horizontal segment, which we have now added. And we can also calculate the midpoint of our vertical component, or vertical segment that we have added in. And we will see that when we combine the calculations, we get the midpoint of our diagonal segment. So let's add in some dotted lines to see what we're doing. If we calculate, again, those midpoint values for the horizontal component and the vertical component. So what's the midpoint value of the horizontal component? Well, we're going to take the average of the pieces of the coordinate that dictate horizontal movement. So that would be the average of the x components. And the midpoint of the vertical segment here would be the average of the y components, and they control vertical movement. And as we can see here now, we're able to determine what the midpoint coordinate would be for this red dot. And that would be its x component should be x1 plus x2 over 2. And its y component should be y1 plus y2 over 2. And that is the midpoint formula. And this is for the xy coordinate plane. It is calculated, or I'll just say it's equal to So this is a formula you should know, and all you have to think about when you calculate this is to determine my midpoint coordinate, average the x values, comma, average the y values. If you can do that, you can determine a midpoint between two given coordinates. So to show you a quick example, it says here if C is at coordinate -2, -1, and D is at 4, 2, find the midpoint of the segment CD that would connect C and D. So we would say we know we can calculate a midpoint now by averaging the x's and averaging the y's. It's that simple. So we can say the midpoint will equal, if I average my x's, again, this is x1, x2, we can think of this as y1, y2. We're going to do -2 plus 4. So again, to average, sum everything and divide by however many you are summing. And then -2 plus 2 over 2. We simplify this. We're going to get 2 over 2 and 1 over 2, which is equal to 1, 1/2. That is the midpoint If you wanted to quickly plot those points and verify that that would be in between, you can do that. But that is how we utilize the midpoint formula if we have two endpoints seeking a midpoint. Now, in the second example, we're told the midpoint and we want to find where the other endpoint would be. So again, we're still going to leverage the midpoint formula, except in this case, we know what the midpoint's going to actually equal. So we have what the midpoint will equal, and we know how that is calculated. We know it's calculated by averaging the x's and averaging the y's. If R represents our x1, y1, and T is going to represent our x2, y2, we can just plug in what we have and solve for that x2, y2 piece that we're looking for. So now I'm going to replace x1 and y1 with the values that they give me for the R coordinate. Now, here's the trick to this problem. There are two equations here. We know that this piece right here ends up equaling -1, and we know that this second piece equals +1. So we're going to have to set up two equations because I have two unknown variables that I'm ultimately looking for. So we're going to say this part of our midpoint formula we know should equal the x-coordinate of my midpoint, which is -1. And then the second piece of my midpoint formula we know should equal +1. And we're going to solve these two things separately, and they reveal the coordinate t. So we multiply both sides by 2, add 6, same procedure over here. So we have a coordinate for t, which we defined as x2, y2. We solve for each one. So t is 4, 3. If we want to verify, again, that that is accurate to what we're looking for, you can plug 4, 3 back into here. And in conjunction with point R, you should get -1, 1. Or if you're more of a visual person and you want to see that you did this right, you could draw a quick coordinate plane. You could plot R. You could plot S. And if you plot T, you can see that that point S is roughly right in between both. Again, that is not a perfect distance tick marks on a coordinate plane, but roughly I do see that S is exactly in the middle of T and R, so my calculation for T I would expect to be correct. And again, if I want to verify algebraically, I could always plug it back into the formula and make sure I get the value for the midpoint that they gave me. Now over to the distance formula. The distance formula is going to tell us the distance between 2 points on a coordinate plane. So this will find distance or length. We'll say distance between 2 points. Or length of segment connecting 2 points. So let's break it down into a horizontal and vertical component. So if I have some point x1, again this is our x-axis, and x2, if I want to find the distance between them, we've already discussed this in a previous video, we're just going to take the difference between the two and then the absolute value of that. So we could have x2 minus x1 or x1 minus x2. This absolute value allows us to not worry about the order in which or what we're subtracting from the other. Okay? So if we have y2, y1, this is our vertical axis. Again, the distance between the 2 points can be calculated as such. So that's when we have perfect vertical or horizontal alignment between 2 points. But when we carry over to the coordinate plane, if I have 2 points in my coordinate plane that aren't horizontally or vertically aligned, can we still calculate the distance between them? And the answer is yes. If we connect our 2 points, again, the length of that segment is what we're looking to determine. So let's use, so what is the distance here? That is what we're looking for. What is the distance between those 2 points? Again, we can calculate. We know that the distance between these 2 points will be found through utilizing the ideas behind calculating the distance horizontally and vertically. Because what we can do for sure, what we know we can do, again, if I add another point in here, which will be our, again, it travels the same horizontal distance as this point, so its x component is x2. It's traveled the same vertical distance as our point on the left, so its vertical component is y1. What we can do is calculate the distance that's horizontally between, or that is between these two, and we can calculate the vertical distance between those two. And you can see that the horizontal and vertical lines that I just drew are going to run perpendicular to each other. And what have we just created but a right triangle? And we know when we have a right triangle, if we want to find lengths of sides, which will be synonymous with the distance between 2 points, we can use Pythagorean theorem. So let's establish how we calculate the horizontal distance, or the horizontal leg that I have just drawn. The horizontal leg is going to be found by calculating the distance between the x components. So this will be x2 minus x1, or x1 minus x2. The vertical component will be found by calculating the distance between y2 and y1. So we can do y2 minus y1, or y1 minus y2. And now that we have a representation for 2 of the sides, we can find the third with Pythagorean theorem. So we can say that the distance between the 2 points squared should equal the side length, which is the horizontal distance that we've calculated, squared, plus the vertical distance squared. And again, we can think of this, here's our Pythagorean theorem. D squared is ending up as the hypotenuse of our Pythagorean theorem. The horizontal leg we'll call our A side, and the vertical leg is the B side. It's the exact same formula, which is why it's so important to understand the Pythagorean theorem. The only thing you will see is a slightly different formatting. They'll take the square root of both sides, so we just have D equals. And because we're ultimately squaring these absolute values, we actually don't need to use absolute value because the squaring process will make the number positive either way. So this is what you will see. And that is the distance formula. So distance formula is nothing more than Pythagorean theorem in disguise. Over to an example. Find the distance between these 2 points. Use distance formula and Pythagorean theorem. So let's plot these 2 points quickly to get an idea of what's going on. R is at 3, 2. And here's S. Okay, So if these points were horizontally or vertically aligned, we could just count off the distance between them. Or if they were horizontally aligned, all we need to do is find the distance between just the x coordinates. If they were vertically aligned, all we need to do is find the distance between the y coordinates. But in this case, neither of those two things exist. So we have to use distance formula. And then it also asks us to use Pythagorean theorem, and we'll see why we can do that shortly. So distance formula, let's use that first. Distance formula is as follows. You take the difference between the x coordinates, square it, and you add the distance between the y coordinates, square it. So distance between the x coordinates, let's just label these to stay consistent. So this is our x1, y1, and this is our x2, y2. So we're going to do -3 minus 3 squared plus -1 minus 2 squared. So as you can see, we're going to get negative values, but squaring it takes care of that. It makes it a positive. So we're going to get -6 squared, so we're going to get positive 36 plus, and then -3 squared, which gives us a 9. Therefore, distance square root of 45. I mentioned simplifying radicals, so we'll do that quickly. We'll have a 5 and a 9, a 3 and a 3, group of 3. So pull out a 3. What didn't get grouped is that 5 goes back underneath. So the distance between the 2 points is 3 root 5. Because we're calculating distance, again, make sure your answer is always positive. Now, it also wants us to use Pythagorean theorem. So here is another option. If you ever forget the distance formula, you can always do this. Plot your points, so draw your own coordinate plane, plot the 2 points, and then draw a right triangle. Calculate the lengths of the sides of that right triangle. So how far have I traveled between these 2 points horizontally? I can just count it off in this case. We're going to be going 6. How far do I have to count off vertically? We're going to go 3. And then I can use Pythagorean theorem to find out what this distance of this red line would be. I can say 6 squared plus 3 squared equals the distance squared. We're going to have 36 plus 9 equals d squared. 45 equals d squared. We're going to have d equals the square root of 45, which we already know simplifies to 3 root 5. And we can see that either method will reveal the same result. So if you ever forget the distance formula, you can always leverage the Pythagorean theorem. You draw a coordinate plane, plot the 2 points, actually draw the right triangle, so add in your horizontal and vertical leg, determine what the lengths of those legs would be, and then your distance in the coordinate plane, if you're using Pythagorean theorem, your distance will always be your hypotenuse. And that is the conclusion to midpoint and distance formulas.